Okay, good afternoon. We're going to start the afternoon session, and it will be chaired by Pablo Santos.
Hello, everybody. Good afternoon. I'm the chairman of this session that is called Observations and Results. The first speaker is Bernd Garken. I don't know if I pronounce correctly your... Okay, Garken. Okay. And the presentation is about diffraction effects at ETA LEO's occultation in May 2022. You have 20 minutes plus 5 minutes for question, comments, and this kind of thing. So,
thank you very much.
Welcome.
I need it?
Yes.
Thank you. So first, I like to start with my first grazing observation. It was in the year 2009, and I was with Eberhard Bredner in Turkey near Ephesus, and we observed a grazing occultation of Antares. It's a red giant, you know, and it was fascinating for me to see the decrease and the increase in the light of Antares. It's a red giant, you know, and these pictures are made with a Mintron camera. You know, the Mintron camera is a little bit faster than the Vatek. It makes 50 pictures in a second, not 25. And so this is the result of the eclipse of Antares at 50 frames per second. And what do we see? We not only see the diameter of the red giant because it's a very big star, we also see effects of diffraction. So, and there's also an effect of the frequency of the light because it's a red star, and this has also an influence. A good paper for the effects of diffraction is available in the internet from Michael Richmond, and he shows some calculations on the effects. And here you can see, for example, there's a difference between a point in a single wavelength with 500 nanometers and an interval, for example, here 400 to 800 nanometers. If you have several frequencies at the diffraction, the waves in the beginning will be destroyed. Yes, so here the pink line is the result of an interval of 400 to 800 nanometers, and the red dot here is 500 nanometers. And here it's also interesting, 500 to 550. You can see the changing in the frequency. If you have another frequency, the waves get another position at the diffraction. And this is the result if you also have a diameter of the star. If you not only have a spot in the moon, sondern if you have a diameter of a star. For example, Antares or Aldebaran or maybe Betelgeuse have a diameter of 20 milliarc seconds. And if you have a diameter of 20 milliarc seconds, the result was this here. So the waves here in the beginning of the diffraction will be destroyed, and you have a long decrease. It also depends on the wavelengths. Yes? If you have a longer wavelength, the decrease is rising, and that's what we have seen here. That's because it's so long. Because it's a red star, we have a big interval of wavelengths, and we have a big diameter of the star. That all comes together at this effects. Many people believe when we have a red giant, it looks like this. If you take a spaceship like Raumschiff Enterprise and drive to the star, have a look, then it's a big red ball, but that's not right. If you have a red giant, you will see in the middle that it's brighter and it's more bluish. That's a typical view of a red giant because it's not. You have a changing diameter with the frequency, and it's not a sharp border. That's also wrong. You have an unsharp border. So if you have a star in the infrared, it becomes very, very, very big. And if you look to the star in the blue, it becomes very, very small. So if you split this picture in the three colors, red, blue, and green, you have this result: red, green, and blue. And this has effects on the decrease of the star at eclipse you can see it here at an Aldebaran eclipse in 2018. And here you can see the difference between the red light, we used a color camera, and the blue light. Yes, the decrease in blue was faster than in red, and that's an effect of the diameter of the star in the different frequencies. And here you can see it in more details. Several frames here at the end. It becomes to 5 frames or 13 frames, the difference. It's a lot. And this certainly will have an influence on the annular occultation of Leona. It's maybe in the blue total, and maybe it's annular in the red, and maybe it's partial in the infrared. It's possible. So yesterday we've learned a sentence: anything allowed by physics is observed in nature one day or another, and everything forbidden by physics may be observed in the nature one day or another. So it makes sense to check the reality, the nature sometimes, even if you think you know everything is known and you know the result. Have a look. And Galileo Galilei said the same, and that was the reason, because you saw the cannonballs from the Tower of Pisa, the Campanile in Pisa. Everybody believes heavy things falling faster than light things. And everybody was surprised when he took these both cannonballs, a heavy one and a light one, and they arrived at the same time at the bottom. And that's the reason, because he got the stator in Pisa. It's a legend. Nobody knows if it's really happens. Maybe it's not true, and this was the true first attempt. So I like to test the diffraction, and that's the reason for my speech. And what do we need for testing the diffraction if we have a main star, not a red giant, a main star which is a dot? Yeah, we need a sensitive camera, certainly. We need a fast camera. Fast camera is not the same than a sensitive camera. Maybe some cameras are sensitive, but not very fast. Then we need a filter with a small white at the half maximum. Yes, a line filter, because we have seen at different lines we have different diffraction effects, and they destroy each other. Yeah, and then we need much light, because we have a small filter. We need much light, and so a big telescope is helpful, and certainly a bright star is helpful. And I tried it several times, and the conditions were very well. At May last year, there was an eclipse of the star Eta Leonis in Leo in the late afternoon, and the moon was exactly in the south, and it was in spring. In spring, the moon at the first quarter is always very high, so there's a good chance for good seeing. Yeah. And at this day, the chance was really good. It was my third or fourth attempt to try to show the effects of diffraction. This is the telescope we have in Munich. It's an 80 centimeter telescope, a big telescope, the biggest maybe in Bavaria for public use. And at this night, the seeing was really good. I also make a moon picture. I tried to make it a little bit bigger. Yes, it was in Munich. It was half an hour later. Here's the long wall. It's the Riemer bird. It's always a good sign for good seeing if you see the Riemer bird. So you can see the seeing was very well on this night. And this was very helpful to show the diffraction effects. Here also some Riemer. I think that was enough for the moon. And this was a camera I take. It's a color camera, not a black and white camera. And there's a special reason. First, it's a very fast camera. If you use region of interest, it becomes faster. So if you use a region of interest of only 320 to 240 pictures, you can reach 355 files per second, and you can double if you use binning. So you can reach 500 pictures in a second. That's very helpful. And the other thing is this filter here. I told we have to look on a single line of wavelengths, but this is a filter with 2 lines. It's a new filter, and this filter uses 2 lines in the green, 1 line in the green and 1 line in the red. So in combination with a color camera, you can see the effects in the red, and you can see the effects in the blue and in the green, and you can split it. So you have 2 measurements with 1 camera in 1 night with this filter. That was the idea. And here you can see the combination. That's the sensitivity of the camera, and it's interesting. At 500 nanometers, you can have a signal in the green and you have a signal in the blue, but at different exposure times. That's also helpful. And at 650, you have a domination in the red, so it works. It should work. And that's the result. We have to see it several times because it's not so simple to see. It's certainly slow motion. Again. And again. Yes, if we can see it, we can also measure it, certainly. That's the result with a combination of 2 frames, yes. And so it's only 260 files per second, but it's very well visible here with Tangra. That's the first mountain, the first valley, the second mountain, the second valley, the third mountain, and the fourth mountain. It all together takes only 0.04.2 seconds. And the fading is very long. It's 0.2027 seconds. So this is with a higher resolution in time. So with 520 files per second. And here you can see always again the 3 mountains. This mountain is not so clear, but it's also at this position. And again, here this measurement says also it's 0.042 seconds. In the red, you know, it's a double line filter. There's also a measurement in the red. It's not so clear, but here are 2 mountains very well visible. This measurement is made with the software Moonivin. And here's a comparison of red and green. Red and green. And you can see that the mountains and the valleys are in different positions. You can see it more detailed. It's this graphic. Here in the green, you have valleys here, 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 and here. Yes. And in the red, there's maybe a valley here, maybe a valley here, and here. And it's also interesting to see that this mountain in the green is on the valley of the red. So you can say it's surely no effect of fatigue. So what we can say, all diffraction effects are in the range of 0.03 seconds. It's 1 frame, typical when we make eclipses. It's for a total eclipse of a star with the moon. It's not a grazing. It's a grazing. We maybe have other effects and it becomes longer. But if you have a typical frontal eclipse, it's in this range of time. And so for our typical measurements, it's not so important. We will see all diffraction effects only in 1 frame, the last frame before the eclipse. So, and if you like to see more, you can see it on my homepage. It's at astro.de, ESOP22, and .htm. Thank you very much.
Well, we have a lot of time if you have any question here or via Zoom, I don't know. Questions? Yes.
I don't know want to add that I was observing the same event as a GRACE event, northeastern part of Poland near Lithuanian border, which was apart 170 kilometers apart from Białystok. And I had something like 14 contacts, and I have to look closer now to see that diffraction nature, because I did it with 1 millisecond exposure time.
Yes, that would be very
Yeah. Also with 290 cameras, but black and white.
The problem is that you have not
no filter and a very small telescope, like 6 inches only.
But nevertheless, I think that's the last rank, so we will see it right with the brightness.
Thank you. Robert via Zoom has a question. Please, Robert, can you open your micro and
Yes.
ask?
Hello, can you hear me? Can you hear me? Hello?
Yes, I hear you.
Okay. I just wanted to make a comment that there was a
We
very
can hear you. We can't.
Yes.
I don't know if you are speaking or not.
Okay.
Again, please, Robert.
Hello?
Hello.
Yes,
Hello?
I hear Robert.
Yes. Okay. I just wanted to make the comment. There was a very similar presentation given at the Trans-Tasman meeting this year from a couple of observers in Brisbane. And in that case, they did a similar experiment with high frame rates from 2 different sites. So you may want to have a look at that presentation. It's very interesting.
I'm very interested. If you can send me the link, I will be happy.
Yeah, sure, no problem.
Oh, fine. That's all?
Maybe.
Yes, more question, Conrad?
So it's not a question, it's more a remark. Thank you for this presentation. It shows very well that a very old field of observations of total occultation can be used with a new generation of cameras to do the old job, what we did with photomultipliers in the 70s, in the 80s to find star diameter. So with this equipment, it's possible to observe big stars, giants, spectra class K and M, maybe variable stars to different times to see the correlation of the diameter measured by total occultation with the light curve. So it's a very interesting field of total lunar occultation is open now with these high-speed cameras here.
And with different colors. It's interesting to show
Yeah.
that the stars, the red giants, have different diameters and different colors.
And the used software makes some simulation to find the diameter in milli-arc second. So it's a very nice field, and for me it is has not enough activity at the moment for the people. Nobody is doing this. Yeah, that's.
The problem is that the stars should be very bright for these filters, and you need a much lighter, a big telescope. So it was not so simple. I tried several times to show it.
Sure, but you don't need such a small band filter. If you go in a small V filter called Epsilon, it's also possible. Okay.
I think Andrea Rikiki does still these things. I'm not sure.
Yes.
He's still doing it in Thailand.
One of the professionals, very
Yeah. So this is an old thing to, and I only can tell that on the first ESOP 1, I gave a talk on this kind of, we didn't do any measure. We had only a 15 centimeter instrument at that time. And I just found I have to scan it. I found a few 2 years ago, I found some diapositives with pictures from an oscilloscope. There was a transient recorder. You recorded from a multiplier, and then you saw you couldn't see the fringes because the instrument was too small. But you could see definitely the difference between Regulus and Aldebaran. There was in a year, there was an occultation by the moon of Regulus and Aldebaran, and you could clearly see the difference. And this must have been around 1970s.
Yeah. So the blue color, the blue one here versus the blue line. The dot. Okay, thank you very much.
Yeah.
Thank you. And then we move to the next talk by, it's a Zoom talk by Apostolos Christou. And the name of the talk is Extraterrestrial Occultations, the Beagle 2 Experiment. Apostolos, are you connected?
Yes. Can you hear me?
Yes, good afternoon. And we can see
Excellent.
you. So.
Yeah, good to see you folks as well. I hope the weather is better over there. Up here, it's raining. So
here it's very warm and hot.
Okay.
And sunny.
So I should have come, but it was technically difficult. So anyway, is it okay to share my screen?
Yes.
Okay, so I'm gonna do that. Right, let's see. Can you see my?
Yes, perfectly. We can see. Apostolos, you have 20 minutes plus
Okay.
5 minutes for question if any. So go ahead. Thank you.
Thanks very much. So my name is Apostolos Christou. I work at the Armagh Observatory and Planetarium in the UK. And today I'm going to talk to you about a project that I was involved with a great many years ago. In fact, it's been almost 20 years since I worked on this project because it carried with it the novelty factor of being carried out from the surface of another planet. I thought it would be of interest to this audience. So I'll start with giving you some background. So the more seasoned among you would remember what became the Mars Express mission. And so that was touted as Europe's first mission to Mars, approved in the late 1990s. It rose out of the ashes of what was then Mars 96. The Russian mission essentially was a reflight of instruments that were built for the Russian mission. Now, Mars Express carried with it a small lander that was built in the UK. The lander was called Beagle 2, in reference to the ship that brought Charles Darwin to the Galapagos Island. The mission of the lander was to analyze Martian soil and look for signs of present or past life on Mars. And the lander was supposed to operate on the surface for 3 months after landing. Now, yes, so the landing site was to be near the equator of Mars on a large, in a large impact basin called Isidis. Well, some of you may know that it's not possible to predict a priori exactly where the lander will land, but in this case, if you like, the uncertainty in the lander's location before the lander separated from the orbiter was of order 100 kilometers by 50 kilometers. So, so history records, of course, that Mars Express launched on a Soyuz rocket in June 2003, and after several months of cruise, the lander separated from the orbiter. I think it was about six days prior to arrival. The picture on the bottom right here is a picture taken from the orbiter showing on the extreme left the capsule just receding in the distance. And then after 6 days, the lander would have went through the atmosphere, landed on the surface, opened its petals, and communicated with not the Earth, but either Mars Express or one of the assets that were in orbit at the time. So, so Mars Express did reach Mars. 6 days later, it went into orbit and became the fantastically successful mission that we know. So it's actually operating right now, almost 20 years after it reached Mars. Unfortunately, nothing further was heard from Beagle 2, and there was a lot of speculation about what could have happened. Many years later on, in images of the surface taken by the Mars Reconnaissance Orbiter, that's a NASA orbiter, the Beagle team identified what they believed to be the components of the lander's EDL system, so entry, descent, and landing system on the surface. And they made what I think was a very convincing case that one of the white dots that you see on the left there was actually the lander, and further analysis showed that the lander was in a partially deployed state. In other words, the petals that cover the if you like, the instrument deck during EDL had begun to open, but apparently not all the petals actually opened up, and that in fact, that prevented the radio antenna from deploying. So this then meant that the lander went, it actually came very close to actually being able to operate on the surface. But of course, in the space business, you know, if you like, a millimeter is as good as a light year. So if it doesn't work, and doesn't work. Now, so now I'm going to take you before launch. So during the time when the lander's mission was being developed. So one of the problems that were facing the engineers, well, actually the scientists and the engineers, is how to locate the lander on the surface after landing. The landing uncertainty was quite high. It was, as I said, 100 kilometers by 50 kilometers. So that was an incredibly large area to search if you do it, you know, by scanning through the landing ellipse with high resolution images. And you have to remember that at that time, orbiters with very high resolution cameras like MRO were not there yet. We haven't even launched. The only orbiter that could do this was the Mars Global Surveyor. Now, normally, the way that you would locate the lander on the surface is that, first of all, you would look at the radio tracking data, and that will help you narrow down the landing site within a small fraction of the landing ellipse, and then use that new estimate to search from orbit with a much fewer number of images that you would otherwise need. However, this is not an option for Beagle 2. This is a completely passive lander from separation from Mars Express until deployment on the surface. So no radio data. And even after the lander deployed and started to send radio signals, there was no direct to Earth communication. So the information would be relayed to Earth via the existing orbiters like Mars Express or the other NASA assets in orbit at the time. So it was not an impossible problem to solve, but it was difficult. So it is considered worthy of looking at novel ways to do this. So at the time I proposed to Professor Mark Sims, it was at Leicester, who was then project leader for the lander, that we could use the moons of Mars. In fact, not the moons themselves, but the shadows that the moons cast on the surface of Mars. So if you think of it from the point of view of an observer on the surface, the transit of the shadow would look like, if you like, a kind of eclipse of the sun or a transit of Venus. So here I show a simulation that I made for the project. I think I use Mathematica to do this. And anyway, so this is just to show what in theory what such a transit would look like. So it's not exactly a solar eclipse, right? But it's not exactly a transit like the transits of Venus that we're used to. It's in between, if you like, an annular eclipse of the sun and transit of Venus. So quite a different experience from what we're used here. So and such a transit would last about half a minute, so quite fast. And the transit depth, since Phobos is too small and slightly too far away to cover the entire disk of the sun, could reach 40% of the incident direct sunlight. So let's look at this idea in detail. So the idea is that I obtain a light curve of the eclipse, then I calculate the transit. So I then calculate the mid time of the transit and the depth of the transit, or equivalently the impact parameter, and I use that to determine the latitude and longitude of the observer on the Martian surface. So one way to think about this is like a FEMU campaign, so a campaign to observe unusual phenomena of the Galilean satellites, but in reverse. So instead of trying to find out something about the target, you're trying to find out something about the observer. So that's the theory. In practice, in order to be able to do this, actually do it, you have to meet several constraints. The most obvious one is that you need to have some kind of instrument on the lander that can obtain the light curve for you. Unfortunately, if I'm correctly, the camera could not obtain images at the required cadence to give us a usable light curve. But there was another instrument on the lander, a UV photometer, that we are actually able to use. If I remember correctly, it would obtain measurements a few times every second. So it was actually, if you like, just what the doctor ordered. It was really custom made for this observation. Also, the accuracy with which you can determine the longitude depends on how well you know the location of Phobos and its shadow, and also how well you can keep accurate time on the lander. And these are both problems that we had to solve during the development of the project. Another constraint is that it has to do with where you have to be to see the eclipse. So it's a bit like observing a total solar eclipse on Earth. So now Phobos orbits Mars in an equatorial orbit. So because Mars has seasons, the shadow will always fall on the winter hemisphere. If you are at the site near the equator, like we expected Beagle 2 was going to be, you will see a group of transits once every equinox. So equinox at Mars. So because the Martian year is equal to approximately 2 Earth years, transient seasons would occur once every Earth year. Now remember that the lander primary mission was 90 days, so that presented a problem. What if the transits would occur well after or worse before the primary mission? Well, it turned out that we were lucky, and we did the calculation with ephemerides from SPICE, and actually find out that transits would take place halfway through the primary mission. So that was an amazing stroke of luck. And furthermore, a lander would have been able to see not one, but several transits. And in fact, 2 transits were actually necessary to remove the ambiguity in the impact parameter. So, so I wrote a piece of code to actually that takes us input the transit measurements, and so it's like a black box where on one side you give the transit measurements, the time of minimum light, and the impact parameter, and on the other side you get the longitude and the latitude of the observer on the surface. So here I've actually placed the lander exactly at the center of the landing ellipse, and the blue asterisk that you see occupying a regular grid is actually the initial guesses that I start with and iterate my code until it converges. So, so the result you can see in the form of the green and the red points near the the center. So actually, it turns out that this estimator is quite robust. So no matter where you start it, will always converge in a vicinity of the truth, if you like. Now, the uncertainties that I obtained for this process was in the region of several kilometers for the longitude and about 10 kilometers for the latitude. So in terms of the reduction in the area that has to be searched it's between 2 and 3 orders of magnitude. I guess the other thing is I also tried to I implemented this in 2 variants. In one variant, I used both the time of minimum light and the impact parameter, whereas in the other, I only use the time of minimum light. And it's because I have the advantage of being able to observe several transits from any one point on the surface. So you see slight differences in the in uncertainty of the estimates, but the difference is within a factor of 2. So this tells me that had we been able to implement this on the lander, it probably would have worked. Now, we also have to factor in the uncertainty in the Phobos ephemeris, and that probably would have added like a factor of 2 increase in the uncertainty, but still it would have been able to reduce the search area by at least 2 orders of magnitude. So good news there. So okay, so now unfortunately we're not able to complete this experiments, but there is a happy epilogue to this. Now, when Mars Express and Big 2 travel to the surface, travel to Mars, they're not the only spacecraft that were heading to Mars at the time. There's also the 2 rovers that we'll later name as Spirit and Opportunity, and these, as we know, those were fantastically successful. They operated well beyond the primary mission duration, and one of the things that they did was actually they constructed time-lapse sequences of the actual transits of Phobos from the surface for the first time, and in fact also Deimos. So you see the transit of Phobos is more or less like the simulation I showed you, and the transit of Deimos there on the right panel looks like a kind of beefed up version of a transit of Venus. Now, later on, after those 2 rovers, we had Curiosity, and this actually came with a better camera and repeated the experiment at a higher resolution. So here you can actually see the irregular shape of Phobos, and actually on the right panel there you can actually resolve the disk of Deimos there. And finally, last year we had Perseverance. Perseverance carries with it this color video camera. So now you'll be able to experience a transit of Phobos across the sun in color with enough resolution to see sunspots. Now his observations were not done to find the location of the rovers on the surface. The reason that these observations are now made is very much the same as for the FEMU campaign. So the scientists are trying to tie down the secular acceleration in longitude of Phobos and perhaps Deimos, and then try to through that trying to constrain the interior of Mars. Now, this is where we are now, but if things keep improving, and perhaps in 100 or 200 years, there will be like human beings living on Mars. Well, it's not too difficult to imagine that perhaps a member of the local IOTA section would go out with a telescope, try to observe what so far has been done only with robots, but at the moment this is just a wish. So that's what I had to say. Thank you very much, and I'm available for questions. Can you hear me?
Thank you, Apostolos. There is time for a couple of short questions, if any, here in the room.
Please
Any
fire
question?
away.
In Zoom, Nico? No? Okay, so no question.
Okay.
Apostolos, thank you very much again. We thanks again.
No
Thanks.
worries. I think I'm due also to give another talk in an hour or two.
Yes, at the end of the conference. Thank you.
Okay,
Okay.
no problem. I'll stop sharing my screen. Just a minute.
Okay, then we move to the next talk by Miguel Cretlow, about on the stellar occultations by comets 28P and 430P. Mike, you know that you have 15 minutes plus 5 minutes for questions, starting when you start.
Be in time, I don't think so.
This is yours.
And how do I go forward and back?
Yeah, with the arrows.
Up and down.
You want this?
Okay. I don't mind. Oh, can. No. Okay. So thank you very much. Yes, the motivation why I wanted to give this brief presentation is were two observations this year, two events, which motivated me to give this presentation. But actually, my interest into comets or occultation by comets goes back a couple of years, when we had this ESOP at Guildford in UK, where I had a long chat with Richard Miles from the British Astronomical Association. He's working since many years on the comet / Centaur 29P Schwarzmann-Wachmann 1. And so it was very interesting. He's monitoring this comet for many years, which is very famous for its outburst. And so I thought it would be interesting to try to get occultations by this object to measure the size directly. So in fact, my interest in comets and centaurs goes back a couple of years ago. And so this closes now the circle. I'm working now here at the IAA, studying TNOs and centaurs, and centaurs and comets have some relationships, short period comets. So it's not too hard to explain now, my boss, Jose Luis, that I'm spending all the time on comets. So Yes, as I mentioned, this objects and the short period comets and the centaurs, they have something in common. So there are some relationship. We believe that objects like centaur, they are coming from the trans-Neptunian region, and they spend some time between the orbits between Jupiter or Saturn and Neptune, but that's dynamically unstable. So they will remove from there. Either they become short period comets like the Encke-type comets or Jupiter family comets, which is a big family, or to the right, the Chiron type comets. So as you also see, this type of objects, they are differently involved. The trans-Neptunian objects, of course, because they are so far away and they are not so much involved like the centaurs, which are sometimes used as a proxy for TNOs because we can study them more easily. They are brighter. And on the other side, we have this short period comets. And if you look on the right-hand side, you see this famous image of Arakoth, which was observed by the New Horizons extended mission some years ago. And if you look at the left side, you see this image from the Rosetta mission from of comet 67P Churyumov-Gerasimenko or Chury. And if you see there, a really nice similarity. And so just have to look, which is a pointer. Yes, and here at this line, I mentioned this comet or centaur Schwarzmann-Wachmann-1, which is in the transition stage. So to study also these objects, also comets and centaurs, is very interesting to get a better understanding of this. Yes, of the small bodies of the solar system and the solar system itself. The problems, the challenges for occultations by comets is they are typically small. Some, like Schwarzmann-Wachmann 1, they have several 10 kilometers of size, but many others are very, very small, just some kilometers if you look at the nucleus. If you think, okay, occultation can also be observed due to the coma. The coma, the optical density is very low. So usually, if at all, you would see some light drop only in very dense regions of the coma, close to the nucleus. And one of these pulses, or which is very famous, was comet Hale-Bopp. Probably is one of the first observations, where you see here this light drop, which was observed, yes, by the comet or by the close to the nucleus region. So that is one of the challenges. And if you look at these images of comet Schwarzmann-Wachmann 1, you see that within weeks we have such outbursts. And of course, if you have such outbursts and, for example, measure the position, do the astrometry, you will have some problems with a centering algorithm of your software. So I have another image which is very nice and very, very recent. It's a composite image. It's a combination of several images of the same comet, and you see here over 6 weeks the development of the comet during an outburst, and you see also some structures within the coma. And of course, if you are monitoring this comet, the positions, doing the astrometry, which we need for the orbit, you will have some biases, some problems, and some errors. And if you look at that figure, this is also comet Schwarzmann-Wachmann 1. And if you look here, the yellow dots, this is the brightness, the photometry, and you see here indicated some outbursts, and the blue and the red dots are the astrometrical residals. So you see, and especially during outbursts, you got a lot of images, so you got a lot of astrometry. What you see is that you have here, due to the outburst, due to the development of the coma, you got an increase in the positional error. And for that reason, if you do the orbit computation, usually you have some rating schemes which were made from astrometric statistical analysis of asteroid observations. So, and they don't fit very well. The conclusion, at least to me, is what we tried together with Richard, what I tried in the last years, is to make a careful selection of astrometric observations. This is a similar image, just to show you that's been taken some weeks ago or some month ago at Cala Alto. And you see the asymmetry, and you see also that, for example, if you measure the brightest spot in your image, it is not necessarily really the center of the nucleus itself, but the center, the object itself is traveling around the sun according to the Newtonian laws. So that will bias your observations and your orbit as well. So that is one of the reasons why predictions, why the ephemerides and the predictions of occultations by comets are really hard and have still big uncertainties. So another reason is that due to this activity, you got additional forces like a rocket. So you have to model this somehow. And these models which exist, there are different models. They are more or less suitable for that, but in a model you have parameters, and these parameters you have to estimate. So this introduces additional uncertainty in your ephemeris and thus in your occultation prediction. So that is the reason why we probably have up to now not so many occultation observations by comets as we like to have. One event was interesting some years ago. The second, I see it here. Okay, that's a problem. There's a second curve. It's barely visible, and you see here a light drop of 0.1 magnitudes. It's unfortunately it's not visible. So that was not really an occultation. It was a light drop, probably due to a very close pulse to the nucleus, where the karma or dust the dust was more dense and caused such a light drop. Now I want to come. Oh, it's again not so good visible. Okay, see. To an event this year, early this year, by the comet 28P Neumann 1 in February. This is an oh, that's not correct. It's not an anchor type. It's a Jupiter family comet, and there are measurements of the radius in the literature in comets too, but all of them are more or less that the radius is around 10.5 and 11, 12 kilometers. There's also one reference where an ellipsoidal constraint was given with the ratio of the two major axes or to the two axes of 1.5. And the rotational period is given by about 12.75 hours. And there was then occultation predicted over Europe. This is a prediction which, okay, you don't see it, which I have on my website, which was based on the JPL ephemeris. Here I have a closer look. This is a closer look to this prediction. This is a prediction which was on Cult Watcher using the Comet Occ feed, which is based, as far as I know, at that time at least, on the minor planet center orbital elements. And we had some 3 positive occultation observations. You don't see it. Maybe you see the. Do you see the pointer? No, it's not working anymore. Okay, you see Stefano Spassetti, for example, there they observed the occultation. So you see here that's the prediction on JPL ephemeris. The prediction was about 60 kilometers wrong or shifted, but we had here 3 positive occultation observation, which was very exciting. And I show you the light curves. You see here the light curve derived by Stefano with a dip, and there was another observer, unfortunately not far away, Alberto Ossola, also observed with a even higher time resolution this occultation, which is really now an occultation by the nucleus. And we have also a CCD drift scan observation by Luca Busi and Andrea Aletti, which what you see here, this gap, this is the occultation of the by the comet, which is really exciting because I think it's one of the first occultation observations of a comet. For sure, we have 3 charts, and Stefano wrote a small, nice article in the Journal of Occultation Astronomy. I can really recommend to read it. So the problem is that you don't see the charts. The problem is that I apologize that we cannot see that. The problem is that one of the charts, the drift scan, is really displaced. So we have it was the time synchronization was via NTP. So you have to shift it, but you can make a circular fit, at least for the 2 observations by Stefano and Alberto, which used cameras with GPS. They fit very nicely, and if you shift the 3rd one, you also have a good fit. And this, if you just make a circular fit, you get a radius of about 9.5 kilometers, which confirms very nicely or is consistent with the photometric and thermal diameters derived so far. This were also 2 additional observations with observations they were outside the shadow. Another event this year, or observation this year, was observed by Jan Martin Winkel in April. And this was a prediction, I think, on Occult Watcher of 430p Scotty, this comet, going over Poland, Ukraine, Denmark, and so on. Jan is located in the Netherlands, and he observed one very interesting thing. This is the light curve and of his observation, and you see here there's 2 dips. And well, still it's not really analyzed what's going on there. It's really René, how do I put this from the bottom to the? Can you shift this to somewhere else? Yeah. Okay. So what is going on there? Double star, or what kind of features might be detected around the dips are not absolutely equally in depth. So okay, this needs a okay. This needs further and deeper analysis, but we know from for example from Chiron, where such dips, and from yesterday we know it also from Quaoar and so on, that rings and material around such small objects are possible. Well, for Chiron we are talking about a diameter of about 160 kilometers. I didn't found any reliable size estimate for 430p Scotty in the literature about the diameter. Occult has predicted something, I don't know exactly, 80 kilometers. I don't know if this is reliable or not, but at least there are also observations and papers by Jose Luis where shells or rings around Chiron are proposed. So this event by 430p Scotty might be interesting to look deeper into it. Unfortunately, there's no second observations for that. So I have 3 minutes. Okay. So in summary, well, yes, occultations by comets or centaurs, especially let's say comets, are still difficult to predict if these objects have some activity. If they are inactive, of course, then the astrometry is not so difficult, or it's comparable to the other objects we are studying the last couple of years. But if they have regularly some activity, the astrometry is not so good, and you have to model the dynamics. So this is still to predict and hard to observe. There are only a few examples in the past years which were observed. And of course, it would be very, very interesting to get this direct independent measurements of cometary nucleus sizes by the occultation method. So that's, and of course also probing the environment around such a comet. So I think there are enough reasons to continue on monitoring cometary occultation events, even if the chances are still very small to have a positive occultation. And of course, for that you need predictions. Currently, there are several predictions in the internet. You have the Occult Watcher feed, Comet.org, which is made from Saturday, and you can go to the Occult Watcher website, for example, Occult Watcher Cloud. Another source would be I also first selected list of comets with a diameter, a known diameter more than 5 kilometers. Currently 25 objects. I also make some predictions on my website. You can select different occultation databases like TNOs and comets, for example. And so you are able to have there some predictions. And as I mentioned in the beginning, together with Richard Miles, we had initially our focus on 29p Schwarzmann-Wachmann 1. And on the Journal of Occultation Astronomy, we wrote a small paper where we calculated on basis of his long-term observations he did and selection of astrometric observations outside any outburst. We made our own calculations and predictions for this comet, and you find on the paper some upcoming predictions, which will also be promoted by Richard Miles on the website. So hopefully next year we have a positive occultation by 29p. Okay, fingers crossed. So I think this is the last slide. And if you give me 20 seconds, I can show a quick movie of an occultation by Alberto. Can you just in the folder? In my folder, there was an AVI file. Is there Alberto, Tony? In a loop or something like that. Yeah. So I hope we can show it. No, gracias. Doesn't work. Okay. I don't know why it's want to go to the internet. Oh yeah, okay. So yeah, that is the star. That was a star. Yeah. and you see
Yeah.
really the occultation. That is was 28P Neumann 1, the comet. Really nice, clear picture. Okay, with that, I want to close. Thank you.
Well, thank you, Mike. I think we have time for only one or two short questions again. Jose Luis?
Well, I have a comment. I think maybe one can focus on these two objects because you now have very accurate positions due to the occultations. You can improve the orbit a lot, so you can make predictions of fainter stars. So maybe we need larger telescopes to observe them, but I think it's worth trying to see if there are good events for these two with better orbits.
Yeah, right, of course. Like we do it also in keynotes and so on. The occultation observations, the accuracy of the occultation is very precise. Thank you.
I have just a quick question, Mike. What is the expected size of the nuclei of these two objects? Is more or less no? Or?
Yes, for 29P Schwarzmann-Mach 1, it is assumed that the size is about 60 kilometers. Yeah. For comet Neumann 1, I think the values are yes, around 20 kilometers in size, and for 430P Scotty, to be honest, I don't know if there's really a reliable estimate if there exists something. I don't know. It's but it's a faint comet, so I don't expect that that's really big.
Like some of Centaur, you know.
Yeah.
You have another one in the chat?
Given the diffuse from Michael O'Donnell, given the diffuse nature of a comet, does the magnitude difference between comet and the star need to be large? What minimum Mach data do you require for sexual? Well, one of the big problems is to compute the apparent magnitude of a star of a comet, but we must make the difference between the total magnitude, which also include the magnitude from any activity from the coma, or the pure nucleus brightness. In some cases, the latter one is not really known. So it's really hard to say, especially also for 29P, where we have this outburst or this differences in the magnitude. But well, in some cases, it's the same recommendation as for other occultations. I mean, meanwhile, we are able to measure magnitude drops down to less than 0.1, and one of the initial figure, which was not seen, but on Zoom, I assume that on Zoom the plot was visible with this magnitude drop of 0.12. Which was very clear, and that was due to the coma. So, okay, I think.
More questions? I think we are a bit late, 5 minutes. It's okay. So we thanks again, Mike, for his presentation. Thank you, Mike. Thanks a lot. And we move to the last talk of this session by Robert Urbinskis, I think. And it's about Baltic Adventure, Hyperborea, 23 August 2022. Robert, can you hear me?
Yes, can you hear me?
Okay, you have 15 minutes plus 5 minutes for questions. So you can share, please, can you share your screen and start?
Okay. Okay, can you all see that?
Perfect. Yep.
Yes? Okay.
Yes.
So Greetings from Germany. The weather's improved a little bit here. First of all, apologies that I'm not in Spain today. I was really hoping to be there this year. This is my third ESOP, and unfortunately it's also my third remote ESOP. As you'll see in a moment, I was traveling already a lot this month, so I decided against traveling to Grenada. Even if I would really like to be there, maybe I'll come down to Spain at some other future point in time. Today, I do have a report of a negative observation. I know Conrad has mentioned a couple of times negative observations and this sort of at the meeting this time. And but in this case, we're sort of happy that we had a negative because this is one of the first times that there's been a positive observation from a new country. In this case, it was Latvia. I have Latvian connections. And a few years ago, I made contact with some amateur astronomers in Latvia. So I thought I would try to convince them to attempt some occultations. Just moving on to my introduction, that's the typical sort of landscape you see in the Baltics. That's actually taken in Lithuania. So my introduction, sort of the framework of my talk is fairly simple. The result was negative at all our sites, including those outside the Baltics, by the way. But I would like to talk a little bit about preparing and planning, because we did put a little bit of work into getting people ready for the event. And I think that's sort of interesting for anybody else that's interested in forming a new team. I would also like to talk about what type of equipment we were using. We had 3 observers in Latvia that were using 3 different techniques, all very simple because we were all mobile. There was nobody at an observatory. And of course, what the results were. And also at the end, I would like to talk a little bit about Lithuania, which is next door. So we had some nice experience there as well. Just to give you a little bit of a little bit of a bit of geography for those of you that I get the impression people get the 3 countries mixed up. So I thought I'd put a map up. So Latvia is the middle one of the Baltic states here, sort of on the eastern shore of the Baltic Sea, opposite Sweden, north of Poland. There are a couple of active observers in Lithuania, and they proved very useful to us. At the moment, I don't know of anybody in Estonia that is interested in occultations, at least. There are professional observatories in all 3 countries. So there is a professional observatory in Baldorna, just south of Riga in Latvia. There's a major professional observatory in the north part of Lithuania, which I'll come to in a moment. And there's also a professional observatory and university located in Tartu in southern Estonia. So I hope to get in contact with Tartu at some point in the future. I think it makes sense to work with all 3 countries together. Even if the languages are quite different, all 3 countries are EU members, of course, and Schengen members, so it's easy to travel there. Of course, also NATO members. That's been very important in the news recently, as bordering on Russia and Belarus in the east there. They all have the euro, which makes traveling there very easy. And since several years now, all 3 countries use the euro. They're also quite flat. I think I looked it up, that none of the 3 countries have a mountain that's higher than 300 meters. So that's a plus and a minus. It means you can get a fairly flat horizon quite easily if you get out of the forest. However, it also means you may get fog if you're in a low-lying area. There's lots of forest, and it's also thinly populated. It's very dark. I will show a photograph in a moment that I took just in the farmyard in southeastern Latvia, which is one of the darker places. And I think it's some of the darkest places in Europe if you look at a light curve map, so light pollution map. So that's quite interesting. So this is the sort of preparation we went into. I gave an online talk at the Latvian Astronomical Society, the Latvia's Astronomy Biedrība, a couple of years ago. During the lockdown, actually, I started getting interested in this because I had been to, every summer they have a astronomy camp or astronomy seminar somewhere in Latvia out in the country. So I had made contact with them already, and I gave a talk about asteroids. We then also wrote an article at the end of last year for their local astronomy magazine, which is a general article about asteroids, but it does mention occultations at the back of the article. But we decided at the end of last year we needed a focus, so we put just identified this one event in August. It wasn't optimum. It was a fairly, the star was about 20 degrees above the horizon from the Baltics, about 8th, 9th magnitude, yeah, 9th magnitude. So not really perfect for beginners, but we thought we would try it anyway. And we formed a small group. It was very informal. As you can see in the picture there, there's myself and Carlos and Martins. And we just exchanged ideas on how to do this, how important the timing was, what type of equipment and what techniques to use. During my talk at the Latvian Society, also Oliver Klers helped as well. Thank you very much to Oliver. We also got some pictures and diagrams that we had in our article there. We also formed, so we had every few months a short Skype session to exchange ideas, but we also formed a little WhatsApp group. Martins is very good. He has been making an effort to identify very useful astronomy apps for smartphones. And especially for younger people, smartphones are becoming more and more common. So using them for astronomy is also an idea we had. We ruled out fairly quickly that we couldn't actually use the phones themselves for this event. But in terms of finding times, for instance, I have Time the Sat, which I know is used by the Indian groups, and a couple of other apps we identified were useful for occultation work. And then at the end, we also made contact with Donatas Tamonis in Lithuania, who regularly observes occultations from Kaunas. And so that was very helpful because it gave, even if he doesn't speak the local language, you can see we almost, my Latvian is enough that I could exchange with the people. That helps. But Latvian and Lithuanian are quite different languages. So we exchanged in English with Donatas. And I think that also helped that they felt there was somebody in the area that had some experience. And then just a week before the event happened, the Latvian Astronomy Club had its summer seminar. So I went to the seminar and we formed a few more, firmed up our ideas. There was a plan maybe to go to Western Latvia for an event on the Monday before the event. That got clouded out anyway, but it was useful to have some backup plans. You can see my presentation down the right there in Latvian. Aizklāšanas novērojumi. It literally means occultation observations in the Latvian language. It also makes it a little bit difficult because the word aizklāšanas and occultācijas they're used interchangeably. So I even had to discuss that a bit, what the best words to use in Latvian were. So, but it's been a very interesting experience, and they're reasonably interested people. It's been quite interesting. So this was the event we chose, which was Hyperborea on the August 23. You can see that the path actually went through not only Russia and Latvia, but also Poland and Germany and France and possibly even Spain. Interestingly, it was interesting the day I took off to Latvia at the Munich airport, I picked up a copy of Astronomy and Das Magazin at the shop just next to my boarding gate, and there was Oliver's article about the Hyperborea event. So it was interesting to see that people in Germany were also interested. That was encouraging to see that. So this was the path that we based our occultation, our planning on, and this was from, you can see the JPL orbit there was from June. It didn't seem to have a very large error on the path, and this object has been observed, I think 3 or 4 times before. I'm in good good company here. Roger Venables observed it from the US some years ago. However, there were some path shifts on some of the earlier events, and I think I have an explanation of what's happening there. It is a main belt object, but an outer main belt object. The duration was supposed to be only about 4 seconds. And it was also very early in the morning. You can see that in Latvian time, this was like 3 o'clock in the morning. So it was quite an early, late night for us to actually go out and observe this. This was the plan on Occult Watcher for the evening, and there were several stations planned. One in Poland, I think Anna had planned to observe it from Poland. I think she got clouded out. I didn't hear from any of the other observers in the center there, but I do know that Eberhard was out in the western part of Germany, and he had bad luck that his Max and Moritz were with him, and they both got clouds, unfortunately. There was also one observer way down in France, and he also had a negative event. But we were up here, right up here at the on the right-hand side there, and so we decided to try to distribute ourselves across the path. So this was our team of 3 observers, as myself down the bottom here, Carlos Schuftzans, who was observing with binoculars, and Juris Semniakovs also in sort of the southeastern part of Latvia. It's quite a forested area. There's only one large city, Daugavpils, which I was actually fairly close to, but I was looking southwards away from it. And across the border in Lithuania, Donatas had actually traveled up from Kaunas to be in the path. And he was sort of a little annoyed that he thought if the path shifted, he should have stayed at home. I actually have relatives that live not far from Daugavpils, and their farm was right on the center line. So I just had to go and visit my relatives. so that's what I did. We had been up in northern Latvia for the seminar, and the week before I had actually seen some Aurora Borealis. So we had quite good weather. It was quite hot the week before, but the weather cooled off a little bit, but it was still quite clear. So Juris set up with a fairly large telephoto lens, and he did a drift scan. This is the result. It was quite a clear negative. I think it's about a 2-minute, 15-second exposure there. So he was quite happy that he at least got a clear result. In terms of timing, I had given him a DCF 77 radio clock. I wasn't sure if that would work in the Baltics, but we had information from Donatas that they do work. So he calibrated against that, was able to use a audio process, just make an audio recording of the camera shutter so he could get his timings right and get quite a good analysis of that. So I think we're quite happy with his result. My setup, I used this was the first time I think anybody's tried to use the DVTI remote. So I set up the DVTI connected with a mounting with a telephoto lens and a finder scope set up on the same tracking mount. And I found that quite useful to be able to point the telescope at a particular point. The star was in Aquarius. It wasn't a field of the sky I knew very well. So I took some hours to find where I was pointing, to align the finder scope, get everything working. I had my MacBook running the software. When I run the DVTI, I'm not running the native software that comes with the unit because that's Macintosh. I'm using a MacBook. So Andreas suggested a week or so before I left to try this Astro DMX software, which I also tried out at the seminar just to make sure it was all working. And after the event, I was able to get PyMovie also running to do the processing. So the weather held. It was quite clear. You can see there's the Latvian farmyard where I was sitting. I was on a fairly flat area, quite empty, and was, as I said, also very dark. The photograph I've got at the top there shows the Milky Way, just taken from that night, just with a zenith, a camera pointing at the zenith for 30 seconds. The picture below that is the aurora that we saw the week before, and it was quite a quite a good sight. My relatives were a little bit amused to hear that I was going all out, making all this trouble just to watch a star for 4 seconds. But yeah, we did at least get a result. My main problem was I sat out there, I had a lot of mosquitoes, but they moved away. Then my optics started to fog, so I managed to cover those. And then 10 minutes before the event, my laptop battery went flat. So I had to run inside, charge up the laptop battery because I was running remote. There was no electricity in that part of the farm. But in the end, I had everything running at the right time. So here's a picture, couple of snapshots. This is the field from Stellarium, which I've rotated. So here's Beta Aquarii, and I star hopped with the finder scope down to this field. A couple of stars down here made it a bit easier to find. And this was a typical snapshot. I wasn't doing any dark subtraction, so the signal to noise wasn't great, but the star is visible in all the frames. So it was a fairly clear negative. And here is another test picture I'd done of the Pleiades the week before. And this was my light curve. So the green one is the light curve. You can see it is quite low signal level, but there is a PyMovie was able to, unfortunately the tracking does seem to have drifted during the 2 minutes that I took the video, but PyMovie was able to track both stars fairly easily and came up with a fairly standard light curve. I expect maybe the dipping on the right-hand side of the reference, the red one is the reference, that could be from the optics starting to fog again. So that was what I saw of this result. And we've written up the reports and forwarded those to Eric. The other observer that we had was Carlos, and he was on the north edge of the path. Early on, Carlos kept asking how accurate the timing had to be. And he was concerned that if he was visual observing, that he would have to do personal equations and blah, blah, blah. And then he thought, well, if he aimed to not observe the event and just to monitor the star outside the path, then a negative would be still useful. And so we encouraged him to try this. And we've also had a couple of other people in the Astronomical Society that have said they may be interested in future events. So for a visual observer, they can just sit and watch the star and just note their beginning and ending times down to a second. It doesn't have to have the millisecond accuracy. It does need to be at least a second accurate. And then they can say, okay, I was outside the path. And Carlos took the approach, how close could he be to the edge and still not see an event? So he planned to get quite close to the 1 sigma limit. As it was, it turned out that he was actually outside, not outside the northern limit, but he was actually outside the southern limit because the whole path shifted past him. So that was also interesting. So as I said, everybody asked me last week. We had a meeting of the Latvian Astronomical Society online last week, and everybody said, "Well, so what happened?" And I like the quote that I got back from Bob Anderson, who said, "Well, that's the way the cookie crumbles." I guess we've all had negatives at some point. But what I did afterwards was to try another prediction using an MPC orbit, and it appears that the path may have shifted north of us. And if you look at where our observers are, these green mobile points down here, and where the French observer was down here, who also saw a negative, it seems to suggest that this orbit seems to match the result better in terms of nobody seeing an event at all. It's only one suggestion, of course. I'm sure we could find any number of possible paths, but I thought it was interesting that the error bars are also larger on this. And when I download the horizons plots for this object, it appears every 10 years or so to get a very fast change in its orbit parameters. And I suspect what's happening, it's getting an interaction with Jupiter, getting a bit of a kick or something. And it would make the orbit, the elements changing more rapidly than normal. So it could mean that the errors could be higher. That's just a theory I have. I did briefly discuss it with Dave Herold. We would like to, of course, be able to rely on Gaia in the long run for orbital data. But it would be interesting to see what the different types of orbital predictions would give for this object, especially because there's been shifts in the past. So that may also explain some of the shifts in the past. After the event, my wife and I went south across the border a couple of hours away, and we met up with Donatus, you see in the picture down the bottom left. And we visited the Molietai Observatory, which is the professional observatory in northern Lithuania. They have this very nice, this big silver building is actually a modern astronomy center and museum. So you can visit that, it's quite impressive. Sort of about culture and astronomy. There's a nice park there you can walk around. And we also talked to some of the, one of the professional observers, astronomers there at the observatory, and they also said they may be interested to have a copy of our article in the Lithuanian, they have a yearbook, Lithuanian yearbook. So we thought that was interesting. And there I am back on the Latvian border, going back into Latvia. So just to finish up for my Baltic adventure, I'd just like to say thank you and paldies and ačiū to my Latvian and Lithuanian friends, especially Carlos and Juris and Mārtiņš, Elvira on the farm, and to Donatus, of course, in Lithuania. And it's a nice foggy morning picture taken in Latvia. Thank you.
Thank you, Robert.
Okay, we are out of time. I think there is only time for one quick or very short question. There is one there, the Zoom. Okay. Claudio, I don't know if you want to ask something.
I can see there's a question from Christian Weber there. Yep, about the Astro DMX software. That's sort of a Linux-based software from the UK, which is freeware. And Andreas has also identified a couple of other software that can work with the DVTI. However, it doesn't have the full set of features that the native software from the DVTI can do. So, for instance, I can't do ADVs with the Astro DMX. I could only do SIR files, 8-bit SIR, and AIVs. So I did AVI. So I had to process an AVI file in the end. Also with PyMovie, I haven't quite worked out how to do the extraction of the timestamps yet, but that was quite clear on the pictures. You can see the first frame and the last frame and just fill it in by hand. So that's a good thing with the DVTI, that it has the timestamp clearly at the bottom, and you can follow it quite easily. It does have dark subtraction, but I haven't had it working yet on the AstroDMX.
Thank you. Thank you.
Okay, more questions?
Yeah, I can see Claudio's planning to go to Lithuania. Yeah, maybe look on the Mulyatai website. That's where the observers are up in northern Lithuania. I don't have directly an contact, but you could try Donatus as well. Donatus is on Planet Cult, and just email him directly if you want to contact the people in Lithuania. Well, he can also help with the language, although the observer I met was very good English. So.
Hi, Robert, Wojtek from Poland here. You should know I had a private trip to Baltic states this year on July, and I was met with a woman who operates Star Space Observatory. Is it Martina?
Star Space, yes. I didn't mention there are at least 2
Yeah.
observatories in Latvia. And
So
Star Space is
we
one
were
of them.
talking about occultations, and
Okay.
I think they are really will be happy to start it. So if you need a little help, I can go next year, because it's my plan to go next year or another year again to Baltic states, and I can give some talks about occultations. Up to you.
Okay, we'll interact further about that. Thanks.
Thanks.
Okay, thank you again, Robert. We have to move to the coffee break. Thanks.
Ciao, everybody.
We come back, I think, okay, because it's late, at 4:40. Okay, 10 minutes late. Instead of 4:30. Yes. No place.
So I will leave this Zoom meeting room open, and we will resume here at 4:40 in half an hour.
Yeah.
So let's start with the afternoon session. The next talk is by Altair Ramos Gomez and will be about the prediction of stellar occultation by the Space Telescope Eclipse. So Altair, if you are there, please share your screen. Okay.
Hello. Can you hear me?
Put it, yes. Can you put in full? Oh, exactly. Okay. Someone asked for the automatic translation, so we can see the subtitles there. Okay, Altair, you can go on when you want.
Okay. So, hello everyone. I'm Altair from the Federal University of Uberlândia in Brazil. I'll talk about the prediction of stellar occultations by the Space Telescope Eclipse. This is my picture, if you haven't seen me, so you can know. I'll first give an introduction of the problem. I'll talk about the observations from Earth compared to observations from spacecraft, some comments. Then I'll talk about the occultation by Coward that was observed by Eclipse. That was published recently. Then I'll talk about the predictions of stellar occultations to be observed by Eclipse. And finally, about the stellar occultation of Triton in October 6, 2022. There was already commented in this meeting. So first of all, stellar occultations was already observed by spacecraft, in this case, for instance, in situ by Cassini and New Horizons, for instance. I haven't seen if other spacecrafts have observed, but Cassini have observed for the satellites and rings of Saturn, and New Horizons have observed occultations by Pluto and occultations by the Ultima Thule, or Arrokoth, sorry. From the spacecraft orbiting Earth, we already had some observations from Hubble Space Telescope. They observed an occultation by Saturn and its rings in 1991, published here in Elliott 1993. And also, there was some observations by serendipitous occultations from the Hubble Space Telescope from the Fine Guidance System. And it was published by Schlichten et al. In 2009-2012. So
Altair, sorry, Altair.
Yeah.
Sorry, I will cancel the automatic translation because it's really terrible.
It's funny.
No. Okay.
My English cannot be translated very well.
Yeah, someone asked for the automatic translation, but the translation is really deconcentration. Yeah, everybody's reading the really bad translation and not paying attention to the chat. Okay, sorry. Go on, please. Sorry.
So it's noticeable that these occultations had some characteristics, like the first ones, they were in situ. So they were very close to the occulting body. It was easier to observe. And from Hubble, the first one was by Saturn, so it's a larger shadow. So it was hard to miss. And the serendipitous occultation is the name, we cannot predict it, so it's by chance. But what about if we predict and observe occultations by small bodies using spacecraft? Is that feasible or not? Well, when we compare from Earth, observations from Earth and from artificial satellites, from Earth, we can see this is what Bruno showed recently. These are the observers that have collaborated with us in the LuxStar group. And we can see that, well, although we have a lot of observers spread over Earth, there are a lot of regions that we cannot cover, mainly due to oceans or in some countries like in Asia, Africa, and here in South America as well, that cannot be covered for occultations. So there are a larger region that we miss for important occultation sometimes. If we can observe by artificial satellites, we can cover these regions. This is just an example for many spacecrafts available. If we can make observations by many of them, we can create an array of observers that can observe basically every occultation that we pass in this region. But obviously, this is not easy to do. Well, what are the difficulties in observing by spacecraft? This has already been in discussion sometimes. First, if we construct for dedicated observations, this is expensive. I have made some cost estimation for, at least for Brazilian reals, it's very expensive, like 1 million reals for one CubeSat. I don't know how much that would be for European astronomers, but in this case, for us, it would be very expensive to construct and launch some dedicated telescopes today. Well, as you see, there is a lot region to cover, so we require many CubeSats or spatial telescopes to have an array distributed over Earth to observe occultations by small objects. And also it's difficult in predicting stellar occultations because these telescopes are subject to the variations in the gravitational field of Earth. So they require many maneuvers over time. And because of this, it's very difficult to predict for the future. We can also use already existing telescopes, but the ones that are available, usually they do not have the recommended equipment for occultations. As I'll talk about for the Eclipse situation, the smallest exposure time was 3 seconds. So this can be a burden. Also, we'd be required to submit proposals for each of these telescopes. Obviously, this is just bureaucratic, but each telescope will have different equipment. We have to verify each one of them to see if they can observe, which is very worky. Also, is the same problem for spacecraft. It's difficult to have an orbit for this telescope with enough occurrence. Usually, when we talk about these questions, there is always this magic number of 2 weeks prior to the event. We can have a good orbit for this telescope. Okay, so, but this is, in general, we already have observed an occultation by a telescope, and this was the occultation by Quaoar observed by Eclipse in June 11, 2020. Eclipse is a telescope for characterized exoplanets known to be orbiting around nearby bright stars. So this is very specific. Well, we had this occultation was made by the Eclipse team. They already have tried an occultation by Pluto and missed. So just to see that it's very difficult to observe either way, because Pluto has a very good no orbit and is a very large shadow, but even so, the occultation was missed. In the case of Quaoar, they attempt to observe. We had the prediction. By chance, because the occultation was not predicted exactly for Eclipse, but they tried to observe and they observed an occultation. I can show here the light curve for obtained by Eclipse. As I said, each exposure is 3 seconds. So it's about 60 kilometers on space. We also had an observation on Earth by J. Broughton in Australia. I'll show the map in a minute. And we can see for Eclipse, there is a small telescope. We can have a very good light curve because there is no atmosphere. So with this, we could observe this occultation. You could also identify the rings that was presented by Bruno Siccardi yesterday. Okay, this occultation was published by Bruno Morgado recently, I think last month. And it was the first occultation by a TNO was predicted and observed by an artificial satellite orbiting Earth. So this is the first of its kind. It gave us a good feeling to make new predictions and observations by spacecraft, and that's what will be the next subject. Well, this is the occultation by Eclipse by Quaoar. This was observed in this situation. We had an observer on Earth in Australia, and Eclipse that was orbiting in this direction, as can be seen here in the zoom. And the orbit of Eclipse matched the shadow in this green region here. So this is the movement of Eclipse along about 10 minutes, 11 minutes. And we had this occultation happen here. So the results of this occultation was that this is the first detection of occultation by TNO from Space Telescope orbited Earth. We obtained a very good astrometric position, although we had only one positive chord. The Kelps observation, Kawa ephemeris is very good. So we can, although we had two solutions for astrometric position, the second one cannot be due to the ephemeris uncertainty, which is shown in this green region here. The negative chord by J. Broughton was important to constrain the shape of Kawa, as shown here in this map, in these plots. And we also detect material around Kawa, which is not in this specific publication the last month, but will be in the Nature publication that was mentioned by Bruno yesterday. Okay, so for the future, we already have observed one occultation. What we can do for the next one? Because the situation with Kelps is the same. They propose that we can only know the orbit with accuracy 2 weeks prior to the date of observation. So what we can do is try to make some predictions based on probability. In this case, we made some proposal to the Kelps Guest Observers Program. I'm the PI of this proposal. We proposed for observing 5 events. And each event is because of the proposal proposal. Each observation means 1 orbit around Earth of Kelps. So we had about 7.5 hours approved. And all of our observations were approved with priority number 1, which is the highest one. And these predictions were made between 1st July 2022 and 24 September 2023, which is covered by the AO3 proposal. So this is one by the occultation by Triton. That was already mentioned in this meeting. We made also for Kelps, which orbit can be seen here around Earth. We cannot say exactly where Kelps will be, but the Kelps is meant to be in this orbit, following the terminate of Earth, and about 700 kilometers above Earth. So we can draw this kind of the orbit of Kelps given this situation. And we invite everyone to observe the same events that we will observe with Kelps, so we can have different kinds of observations. Okay, so how we predicted these events? First, we have to make the distance between the object to be occulted and the star, obviously, from the moon larger than 5 degrees. The separation between the star and the sun must be larger than 120 degrees. This is constrained by the Kelps team. Also, considering the orbit of Kelps, we distributed many initial conditions for Kelps in this orbit. Let me show you in this video. So we have here, each point would be the position of Kelps in the orbit. We made different initial conditions. And then we make the shadow of Triton here moving. And considering the orbital period of 95 minutes for Kelps, we made the satellite orbit Earth at a constant rate. So with this, we can make this prediction shown in this video. So Triton is moving, and the initial conditions for Kelps is moving as well. Every time an initial condition suggests that it will be above the below the shadow, we mark that initial condition, and we save these parameters. I'm showing here only the initial condition separated by 5 degrees, but in the predictions, we made many more to obtain larger, better statistics. So in this case, you can see that there was around 10 initial conditions that could observe the Triton occultation in 2 situations. We also consider that if the occultation was very slow, the same initial condition would observe the occultation twice in 2 locations, and this would not increase the probability of observation. Okay, so let me just repeat the video if you want to see again. So it comes Triton, and these initial conditions by Kelps, we mark them as possible observation. And we do this, we did this for around 15 large TNOs and predict in that times interval that I just talked about. So with that, we found 5 that we intend to observe. This one by Triton, it's the best one. Oh, sorry. Is the probability of Kelps observing the Triton occultation was estimated to be around 14%. This is the number of initial conditions that would be below the shadow at some time. So for instance, here, these initial conditions around -50 degrees could observe around 100 seconds of occultations. Another would be smaller, but either way, you would observe the occultation. So in this case, just the number of initial conditions over 360 degrees, we computed about 40% of probability of chance to observe this occultation. This is for the prediction submitted, as we didn't have the predicted path of Kelps, only the predicted orbit. Other events, for instance, these 2 are by Coward. There we also got time. We have here the main body, and here the radius of the rings. So to observe the main body, we have around 3% of chance, but to observe the ring would be about 40%. And we can see that we also removed the regions where Kelps would be behind the Earth, obviously because it could not observe the occultation in these cases. So these 2 occultations are in May 2023. So if you are here in New Zealand and Australia, Hawaii, please try to observe this event as well, because it will be very interesting. The last 2 occultations are these ones, one by 2002 MS4, which estimates the probability to observe the main body with 6.7%. We don't know if it have a ring or material, so we could detect something else besides the main body as well. And this is in July 2023, and the last one is this one by Chiron, which I show here about 1% of probability to detect the main body. With the estimated size of the ring, of possible ring, we can is about 2% chance of observing the ring. And these ones are the ones that we got time approved for the Kelps mission. So getting to the detail of the stellar occultation with Triton, this, as I said, has about 16% of occultation. This was predicted before we had the actual predicted orbit. So this is because the Kelps release this predicted orbit every Sunday, and each file has only 4 months of data. So we could only have the predicted orbit of this occultation that is in October, in the beginning of June. So with this, and every file does not have uncertainty in form, so we have to compute. And now we can try to see if the occultation is observed or not. CELPS also published the restituted orbits daily, and we computed this restituted orbit with the predicted one to see what we can expect for the epoch of occultation. And we saw that the difference between the prediction, the predicted orbit, and the actual restituted orbit is smaller than 2 kilometers, with 3 weeks prior to the date we used. It is smaller than 30 kilometers, 6 weeks prior to the date, and larger than 110 kilometers from more than 7 weeks. In the total interval published within 14 weeks, we have about 200 kilometers of difference between the predicted orbit and the restituted one. So now that we are about 1 month from the occultation, we believe that we have about 30 kilometers in the error for the prediction of the CELPS orbit. And as I say, we are updating the orbit constantly to verify if the occultation is feasible. But for the moment, we believe it is. Because all of the orbits that we downloaded since 29 May until 4 September, all of them suggest the occultation will be positive. As you can see here, we have Triton, and here is the position of the star relative to Triton as seen by CELPS. So all of the predicted orbits suggest that the occultation will be positive, which is very, very good. Comparing to the last one, we have this, I would say the main observers that I'm aware. We have 2 observers on India, HCT and DOT, and the CELPS orbit. So all of them is expected to be positive. And as I say, so these are the ones that I'm aware of, but there are other regions that should observe, if possible, in Japan or Korea to increase the possibilities to observe the central flash. However, recently we made some corrections. We observed Triton to obtain astrometric positions, and we correct the prediction with some offset. We estimated an offset about 15 milliarc seconds to the south. So this is now the expected path or expected chart of these 3 telescopes I mentioned. So now it's better to observe here in Japan, north of Japan, north of South Korea, China, and central India. Okay, so this is for the CELPS. We also have made some predictions for occultations by James Webb, which is the next step. I've been working with Pablo in these predictions, and he will talk more about this in his presentation. Okay, so that's it. Thank you.
Thank you very much, Altair. So the talk is open for questions.
Hello, Altair, can you hear me?
Yes.
I had a couple of questions. One of them is just now from the map you showed of the predicted chords for October 6th on the last 2 slides, if you can go back. There is a curious thing here that we don't really see often in the occultations, which is that the chords are not parallel. And so the question is, if some software like Sora, which you're used to, is prepared to handle chords that are not parallel to obtain a final result?
Yes, because what we use are the positions on the space of each instant of immersion and emission. So it doesn't matter if the shorts are parallel or not. It may be a problem to consider the uncertainties. I don't recall if, well, we consider the uncertainty in the direction of the shorts, but since we do the fit in the direction, the right direction, we still, I don't remember if we correct the direction, the uncertainty from the direction of the short to the right direction to the fit. I don't remember, I don't know if Bruno remembers, but yes, we can fit in these cases. And they are not parallel because of the difference velocity between the observers.
Can I ask another one? You also had that animation that showed how many initial conditions of Cheops would allow to observe the Triton event, but it seemed that 5 of them were during the daytime, or at least during twilight. My question is, given the altitude of Cheops in our atmosphere, or just in our orbit, what kind of restrictions do you have for the sunlight? What kind of hours do you need to avoid?
Well, as I've done here, so these are the constraints. Sorry, the constraints that the Cheops team has given us. So the separation between the star and the sun must be larger than 120 degrees. So it doesn't matter if it's in this region we see it's daylight, because for Cheops it would always be daylight because it is just above the terminate of the Earth. So if you point in the direction of the sun, you would observe the sun. But in this case, it's observing in the opposite direction. So yeah, it doesn't, for Cheops, it doesn't matter if on Earth it's in daylight or not.
Okay, thank you.
Maybe there's also another way to use space telescopes for occultations, stellar occultations. Telescopes, some of these telescopes are as big as a minor planet. The James Webb Telescope has a big diameter, and so maybe it's possible to see an occultation by a star with the James Webb Telescope from Earth. And maybe it's interesting to calculate it.
Okay, so the James Webb.
It's an uncommon idea, I know.
Yeah,
but then I read
in front of the star.
Prediction of occultations by this telescope, space telescopes. That was the first idea.
Yeah, to study the star. Maybe well, but James Webb has 6 meters in size. I believe the star would be larger than that.
It's bigger. It's like a tennis square, I've read.
Yeah.
Can I just comment that when I showed the lucky star prediction for this event, it showed the RUWE position uncertainty for the Gaia data was a high value of 6, indicating it might be a multiple star or double. So just be aware of that if you're doing analysis of the light curve and positional estimates as well.
Yeah, this is important. Yeah.
So I have a comment also. 2 or 3 years ago, I was in Stuttgart in the university, and they had their laptop satellite that they use only for practice. And they were pointing to the Earth. So I asked them if they can point in the other way. And they say yes. So they calculate the magnitude of the star that they can use. And it's what, about 8 or 9. So the idea at that moment was, what happened if we know that a lot of satellites that they can point to these shadows can observe these occultations. The question is so difficult to predict for each telescope, for each satellite? I mean, if it's... Yeah.
Yeah, I would not say difficult. Maybe, well, you should.
Maybe time consuming or
yeah, maybe time consuming, but not difficult. The problem, as I said, is the orbit may be not trustful as we would want, depending on the how much far in the future we are predicting. Yeah.
Maybe also a common idea, maybe it's similar to your idea. We are all angry about the Starlink satellites we all see over the sky in the summer. And maybe the shadow of a minoplanet hits a Starlink, and then we can see the eclipse of a Starlink satellite. Also an idea.
So we can use the orbit of the minor body to make more precision the orbit of the satellite, for example, as made in Beagle too.
There are so many Starlinks, maybe there's something useful.
Yeah. There is a comment or question on the chat. Why can I not see the chat here? How would the velocity of the satellite impact in the accuracy of the result? Yeah.
Yeah, well, the velocity itself, it's not a problem, I would say, because what we have is this. Usually if the velocity is higher, so the size of the magnitude drop here, the size of the short would be smaller, and then you would impact in the determination of the instance. But the velocity itself, I do not see much problem.
Yeah, I think it's in the observation of Quawar that you show the shadow and then the trajectory of Cheops that is moving. Yeah. Next one. Yeah. So the telescope is moving.
Yeah, the telescope's moving, but
how precise you know the velocity? You need
this is yeah, okay. This is very precise. As I remember from the Cheops team, along track, let's say along orbit, the uncertainty in the position is about 200 meters.
Okay, more. There is another comment in the chat if you want to read it. Satellite could move 300 meters every 40 milliseconds. Okay. Comments, questions? Okay. Thank you very much, Altair. And we move to the next talk. So next talk is by Pablo Santos Sanz, and he will talk about stellar occultation by TNOs from James Webb Telescope? Question mark.
Thank you. Can I use the it's working? Okay.
2-1. 2-1, quindi una bella vittoria questa. Sì, sì, dicevi, oh, Giacomotto, una pippa. Giacomotto realmente non c'era. Come non c'era? È arrivato adesso. Giacomotto era in tribuna a guardare. Sì, non c'era ancora firmato. Però non c'era mia.
Can you mute Paul?
Mute everybody. Yes.
Okay, then I'm going to talk about stellar occultations by TNOs from James Webb. You know from the previous talk that it's possible to observe this kind of occultations. I don't know why this Rene, please, if you can. Okay, my motivation started a few years ago. Someone from James Webb Space Telescope contacted me and asked me to lead a focus group to study the feasibility to observe stellar occultations from James Webb. A few years later, we published this paper, I think it's from 2016, where we show our preliminary results about this possibility. Thank you. Okay, here you can see at this time we identify a few pools of big trans-Neptunian objects and centaurs that could be close to the star seen from James Webb. This was done for the period of 2018 to 2023, because the expectation at this time was that the James Webb was launched in 2018. At the end, it was launched at the end of last year, 2021, and so this is now useless. Again, I don't know what happened. Okay, well, as you know, this is the paper by Bruno Morgado about the first stellar occultation detected by a TNO detected by Cheops, by a satellite, by a space telescope. And this is again what, okay, I'm not going to stop here a lot. The prediction and the light curve that also Bruno saw. Well, so from James Webb, this would be possible to do something similar. Yes, but in the case of James Webb, the predictions of these events visible from the telescope are really challenging due to the chaotic motion of the telescope around the Lagrange point too. This is the main problem we have. Well, even if it's challenging, I apply to get time to observe this kind of events. I apply within the Heidi Hamel guaranteed time, and finally I got time. Well, the project is called Unveiling the Kuiper Belt by Stellar Occultations. And this program is only devoted to observe stellar occultations by TNOs or centaurs from James Webb. Some technical aspect about this proposal. The observation will be made with these two filters, in principle using the near infrared cam, James Webb Space Telescope. We choose these filters with the idea to maximize the flux from the star while minimizing the reflected flux from the TNO or centaur. Of course, these filters can be, we can change or choose another filter, taking into account the colors of the part that will be occulted. We will use the smallest subarray, that is this sub 64p, in order to increase the frequency of observations. Typically, we will observe at around 6 Earth. The total time we have is 2.2 hours. This means that we expect to activate the target of opportunity 3 or maybe even 4 times. And this is what they call a non-disruptive target of opportunity. This means that we have to trigger the telescope to trigger the observations at least 14 days in advance. Okay, so I don't know if I have. Yes. Okay. What is the strategy we are doing in order to predict these occultations? Well, first we selected the 40 largest TNOs and centaurs, 36 TNOs and 4 centaurs. We are running on a weekly basis prediction for all these selected targets for using Gaia DR2 as a stellar catalog up to magnitude 20. And yes, we run this weekly because the orbit of the telescope is corrected using this station keeping maneuvers, because as I said, it's a chaotic orbit around L2. And every week, every 2 weeks, this orbit is updated and we need to run again using this new orbit. Then we take a look to the prediction, at the prediction to identify favorable events. And if we identify some favorable events, we then refine these events with new astrometry. And we rerun again the prediction for this object. After that, after all this loop, if we are confident with the prediction, we activate the target of opportunity. And as I said, we need at least to activate the observation at least 14 days in advance. Up to date, we haven't activated yet the program. And okay, I just want to show you some of predictions that we have obtained using SORA. Using SORA software. This is for the TNO Ixion. Well, here the prediction maps are a bit different. The maps that we are usually have. This is the position of James Webb for different time, and this is the object itself. In this case, this is Ixion. This prediction is for March of 2023. I have moved that. Oh, this is for 2002 TC 302 for August of next year. Also, it's a very promising. But as I said, as we are running this every week, some of them will remove from this favorable list again. I don't know what happened. Okay, this is another one for 2002 MS4 for October of this year. Please, René, can I? Okay, this is the last that I am going to show. This is Cariclo, also for October this year, for Cariclo and its rings. We also have a few favorable predictions for the next year for Quasar. I think this is also very interesting to take a deep look. And that's all. Just stay tuned, because I'm pretty sure that I hope that for the next ESOP, I hope to have some result of an stellar occultation observer for the first time from the James Webb Space Telescope. Thank you.
Questions?
Hi, just a simple question of what's the distance of the objects you're observing? Yeah, the distance of the objects, how far are they away from the sun or the Earth?
I don't know, the distance of the okay, typical distance, you know,
yeah, so
around 40, 50, yes, okay, if it will 10,000, will be maybe 7 to 20 astronomical units. Yes. But okay, this is not only a question of the distance, it's also the size. Take into account that the biggest nodes are thousands of kilometers in size. But the emission, I don't know, maybe it's not like a million, because the velocity is that, but it's also difficult task due to the small apparent diameter of this object in the sky.
I don't know if this.
Yeah, depending on the star, what is the expected signal to noise that you are calculating for these events?
This, in fact, this estimates of this noise, but because in the paper we published in 2016, we will limit the predictions starting K magnitude 9. But now we are going to K magnitude 20. So
yes,
yes, but I haven't estimated.
So, well,
but I hope that without the atmosphere we can reach. And with this very big telescope.
Yeah, I guess it can be terribly high. I mean, very, very, very high. So no. I mean, the signal to noise ratio may overcome any observation that we do from the ground.
Fantastic. So we will see a fly. A fly of the transit or something like that. Yes.
So a couple of questions. One of them is that I saw that for one of the objects at least, the uncertainty was bigger than the size. So I guess that the probability was not so big. And if there is any cutoff that you're using for the probability that it's positive and positive observation for James Webb before discarding the event.
Yes. Do you mean what kind of criteria?
Yes.
Are we using?
It's like 5-10%. What is your?
The proposal we propose something like the 1 sigma is 2 or 3 times the radius. I think the radius of the object we can trigger. But at the end, I think we are going to do something case by case. So
okay.
This is not a fixed criteria.
So one other question is that this is normally not a problem for the stars that we use, but you're using a very deep search up to magnitude 20, and with Gaia, from a certain magnitude, the uncertainties of the proper motion start going up. And my question is if for magnitude 20, you already start seeing larger errors than those that we are used to, like a few mas, or if they are still not that relevant for the error budget compared to the TNO center.
Yes, I think the most source of error at this case is the uncertainty on the orbital, But in any case, you have the idea we can go there, but we need to use Gaia to build our own stellar catalog using Gaia as a reference. This is a possibility. Imagine that we identify a very pricing of the event by magnitude of, I don't know, by a star of magnitude of, we can try to refine the astrometry of this star with our own catalog. This is another idea, but we are working a bit more under pressure because we need to but this is a possibility that we discuss with the service.
Well, what we heard here now that we get more and more of these observations from space telescopes and CHEOPS or whatever, and this may be even more in the future. And you said it's very valuable, of course, if you observe it also from the ground at that time. So is there somebody collecting these information? So have we to go to all the projects and get the information when what is observed or will be observed by ourselves? So is there some, I don't know, who should organize this?
I don't know if the Rafi and Green, I don't know if either of them are doing this thing, but I think for James Webb, it would be difficult to observe at the same time from the telescope and from the planet because of the distance also the telescope. The telescope is up to 1.5 billion kilometers from Earth, so maybe by chance, but it's difficult to have two colors, one from James Webb and the other.
Okay.
Mike there.
Hello, Mike. I have also a question for the Gaia satellite. We know that they are tracking it very good because it's also in an unstable orbit because they are making position measurements. But for James Webb, I don't know how is the policy tracking, observing and tracking the satellite to get precise position measurements, which you need for your predictions. Do you know what kind of precision they got when they observed the satellite itself to get the
precision disposition, but I don't know exactly the numbers.
Thank you.
More questions? There is in the chat. Okay, can you read it? Are any of these events also observable from any side of the Earth from a campaign? I think no, right? Did you check it? No, I'm reading the previous one. Hi, Pablo. Are any of these events also observable from any side of the Earth for a campaign? Using Webb as artificial star to be occulted, completely dumb idea?
Minor planets. It's not artificial minor planet. Yes, I think it was the idea, but I don't know what you can get from this. Why? Yes, we know the size of the everything. So.
Yeah, I need to move with the mic.
When I stand it right, you have about 6 to 7 frames per second. Yes, that's so. How many frames you will get for the Jericho rings? What are you expecting?
Can't reply you exactly because it depends of the particular occultation. Yes, having the numbers. I don't know if yes, Bruno can. Yes.
Well, can you hear me? Yeah,
yes.
The typical width of the Jericho ring is 7 kilometers, and the typical shadow velocity is 20 kilometers per second. So you need a fraction of a second. So this should be okay. I mean, typically we see structures inside the Jericho rings with a integration time of 0.1 with 10 hertz. We start to see internal structure.
Really high signal and also we have the quality of the photometry because there's no atmosphere. So
Okay, we need to move to the next talk. I don't know. I don't have any presentation for this talk. Who will talk? It's a discussion. Okay. So how will
I think you should sit there, right?
Yeah.
Mike. No. Okay.
Yeah. The lucky guys here with the rest.
Yeah, I guess. Yeah.
Yes.
Introduction. This for gentlemen, they didn't knew that I was this roundtable. So it was my idea that it would be nice, because we have so many professionals and so many amateur astronomers, to have a small roundtable to make an open discussion, feedback, because we have a lot of program collaboration. And so I just proposed this. I got some good feedback that it was appreciated. So
the micro.
Oh, no, I'm not part of the
Yeah, but you are making the introduction. Yeah, but the introduction
in Zoom too. Ah, okay, sorry. So me again, Mike Hedlow. Just as an introduction for this point, I propose that we have a small open discussion, a roundtable, a question and answer session with Bruno Sicali, Jose Luis, Carl Schnabel, and Konrad Buhl. So two persons from the professional side, two persons from the amateur side, because we are so many professionals and amateurs here at this ESOP, and I would like to take this chance to have some kind of feedback and just to make an open discussion. What's currently our collaboration? What's the status? What can be done better? What are the expectations? So I know you are not really prepared for this, so you have to improvise. Okay, thank you very much.
Okay, who wants to start?
Yes. The big boss starts.
No, I'm not the big boss. Yeah, what went good, what went bad was the question here on the paper. So I'm a little bit surprised, as Mike expected. Yes, I think what went good. We feel that we discuss and interact with you with information exchange on the same level, and this is very nice. So the unpaid astronomers feel they are colleagues, and this is a very good behavior, and this shows that the level of amateur astronomy is very high. It is more than what we call citizen science. It is the good word from our friend Dave, unpaid astronomers. What went wrong, or what is negative in my feeling, this is something what is explainable, but you have to understand this. This is a situation that we have different treasures. Our treasure is more or less our money and our time to travel, our time we spend for our hobby. We have sometimes to explain this to our partners, to the wife, to the family. And your treasure are the datas. And when we observe, next day, we send an email in the world what we have seen. You can't do this because you are paid for your produced science, means the paper. So you cover a little bit the data, and we are nervous and curious what's happened. Yeah, I remember this with Polymele. Everybody asked me, what have they observed? Yeah, and I said, I can't say this. This will be a paper. Be patient. Yeah.
I understand why you are doing this. That's normal, but I want to explain you that some people are nervous in the world about this. Okay, so short.
Bruno, or I start replying, then you give your opinion. Okay. Let's see. The way science works in the professional area is a bit complicated nowadays because we are funded by agencies which require you to publish and to provide results, and usually the procedures they follow is they give you good rates if you publish in well-recognized journals, and then the journals require, I mean, that in order to publish in a journal, you have to make a big effort, put together everything with many checks, and those procedures are slow. And also, if somebody publish something without, let's say, reviewing from third parties, that's okay, but that's not the science that we are supposed to do. Yeah. And also, if you publish in a big impact journal, there's the thing about the embargoes and everything. So it's a complicated business. We really would like to share everything immediately with the people, but sometimes that can work, but other times cannot work. So it's a difficult balance that we have to reach nowadays. I don't know. I don't know what Bruno thinks.
Yeah, well, but it doesn't prevent from announcing stuff just after an invitation. For instance, there was a big campaign organized by the Boulder Group in the Colorado to observe the stellar occultation by Pluto in last June from Australia, which also deployed something like 10 telescopes or 12 telescopes. And right after the observation, they did big announcements. We observed, and there was a story like they drove thousands of kilometers and they observed, and there are a few images showing the central flash.
Yeah.
And it does. So I think this kind of announcement is okay because it doesn't reveal anything classified. And then it will.
If you have no conflicts with such an announcement, we would be.
So there would be a conflict, for instance, in a case where we discover a ring around an object, and you cannot say, "Oh, yesterday night we discovered a ring because blah blah blah." But if it's Pluto has been discovered a long time ago, we know there is an atmosphere, and we know it's important to continue. And observing a new occultation by Pluto is important to get the evolution of the atmosphere. So announcing that it was observed, it was successful, it's okay.
Yeah.
So it's a case-by-case situation. So I don't see any conflict and difficulties.
For me, it's not a conflict. I just want to explain you what people are feeling on our side.
So we just have to talk and avoid mishappenings. And if it's okay, it's okay. It was successful, and this event was observed, and it will be important to get the size of the shape of that body. So
maybe it's possible to give some data, not some specific data, but some approximate data.
Well, I mean, then we have to grade them. Everything we can show later, but it should not cause some mishappening that someone will do that later and say, okay. So, but I mean, it's not too difficult to decide on each case what we should do or not. For instance, we got a very nice occultation recently by Quawa, which go further what I announced yesterday, but we'll not discuss that. Okay? We say publicly and discuss with colleagues, but okay. So and I would say it's kind of easy.
It's easy to solve. It's just to talk about this,
yeah.
and that you know what some people in the unpaid astronomers feel.
I do think it's important if it's not sensitive to announce it rapidly, because people will be happy. It's announced, the public will be happy, and they know something is going on, and everybody will be happy because it will be recognized.
Yeah.
So I think I do think it's important. When we observed the Pluto occultation in 2016 from Europe, it was observed thanks to the Gaia prediction. It was DR0 because there was only one star in the catalog. It was Pluto star. And then right after that, Gaia made a press release, and tens of people, amateurs and professionals, observed that Pluto occultation thanks to the position provided by Gaia. This is nice because Gaia is happy, or amateurs are happy, and professionals are happy.
Yeah, but for instance, I'm thinking about sometimes the lucky star predictions are spread through planar codes. Then many people observe and they send their reports, but then eRaster compiles everything, makes a feed, and then that feed goes to the Wikipedia and the citation goes to eRaster, whereas the effort went from the lucky star team. So this causes problems for us. So it's, as I said, it's a difficult balance, but we may we may discuss things, and maybe for some cases it's fine to widespread results, but for others, yeah.
Yes. I fully agree, and we have to understand each other. That's important, and we discussed this internally also in our group, that some people must understand not everybody can be sent in the world with a big trumpet. What you say in this case, that's okay. Maybe some of the unpaid astronomers must be a little bit more informed about this. Considered. Let's work in this way. What do you expect from us?
Okay, so we have the problem of the rich. We have too many of them. We went from a situation 15 years ago where we would observe one occultation or two for as important per year. We have many of them, so we cannot observe everything. So then I would say the main difficulty now is to coordinate scientifically interesting events with the amateurs. Otherwise, we are just buried under a lot of information. So maybe there should be some interaction and say, okay, now we will focus on Quawa because of the rings, or another body because they have atmosphere. But then you have to be careful, because if amateurs observe something we don't want to observe, they may discover something that we didn't expect. Okay? So we should be careful. So if we say only observe Quawa or Trojan because of the loose emission, then we may miss other very interesting objects. Okay? So again, we have to balance this and be careful not to miss opportunities. But I would say that sometimes we may organize maybe better things, like so there will be an event in 3 months from now, and maybe everybody should be ready for this one because it will be very interesting, and please try to observe it. And
to symbolize more such campaigns.
Do whatever you want in between and observe whatever you want or whatever you can, but maybe put in your agenda this event or these few events for the future. So, but it's a matter of coordination and interactions.
Yes. I think we should try to make an effort to emphasize which events we think are more productive from scientific point of view, because from our scientific point of view, of course, I'm very focused on trans-Neptunian objects. But of course, there is excellent science by Anna's team on slow rotators. But maybe we should try to emphasize to the amateur community which events
can be more scientifically productive than others, so they can prioritize or choose which ones they are going to observe.
I was thinking just about it for beginners, and it's important to have some phenomena that are easily visible, and they were interested in future events, and they also will be interested in future campaigns with professionals. But it's very important to have beginners and young people. It's always a problem in our community, and therefore it's not only we need not only TNOs and so special bodies. We need some professional
a big main builder who calls the bright star. It's always helpful to get observers.
I think the Leona event, the Betelgeuse event may be very captivating for the public, because they will be able to see with their naked eye the disappearance of a star. That's I think many people, young people, might
be interested, and then start observing with your own eyes.
Can be very helpful.
So
another maybe issue that I would say, maybe if you observe and if you're curious, don't hesitate to ask questions like, why should I observe this? I mean, don't be shy. There will be an occultation by this body, but okay, why is it interesting? Most of you know, because you know it's a Trojan, so it's a Lucy target, and this body has an atmosphere. But there are so many observers now, so maybe some of them don't even know why they're observing and what is a scientific goal. So we can answer sometimes. Sometimes we can say, oh, it's just a boring main belt asteroid, but nobody cares about it. And in some other instance, they do observe this because this will give you the shape or the internal structure or the atmosphere. Okay. Because for someone who is not in the field, it may be a bit obscure, mysterious, why to observe a specific object. So, or ask to other people, not us, but maybe other amateurs would know.
Or at home. Okay.
I like to make a comment and also a question. It's a little bit related to the beginning. But it has an effect on the amateur scene and the professional scene. We have in the past now, in the last years, sometimes the situation, and it's increasing, that, for example, we have a lucky star prediction, a TNO with a more or less large uncertainty, for example. It's on the page. So, but often you have, for example, this information, it's a lucky star prediction, and you have to send the data to lucky star. But there's also the same prediction of the same object, for example, on Cult Watcher Cloud.
Yeah.
And there are people, they did not look on the lucky star page, but they observe. And maybe they are even positive because the lucky star prediction was not so accurate. And they send it to Planar Cult or whatever. So that's a problem now, because if you say that the lucky star prediction, but another prediction is made by occult or people itself, and they even didn't look at lucky star, and they said, okay, I observed this occultation by TNO 1, 2, 3, and I was positive. So this data policy, this is a lucky star prediction. You have to send the data to lucky star collaboration, might be problematic in some cases. And that's the reason why I want to bring together the amateur side, the professional side, because there are sometimes misunderstandings and could be solved this problem in parameters and quotations.
But you're mentioning that some of the prediction are more accurate than others?
No, for example, if you have a prediction of an occultation by an TNO, it's possible that we have a lucky star prediction, and it's possible there's even an email from us to the amateur side. There's a prediction by an object on Tino or Centaur. Often we send also the disclaimer that is a lucky star prediction, and we should send the data now to the occultation portal. What in general is good, but there are also observers that might be having occultation prediction from other side for the same object, so they are not related to lucky star.
Yes, it is possible that it's the same imputation. It becomes in the Iberoc feed.
What I mean, it might be meanwhile a little bit, let's say, sometimes rise a misunderstanding if we disclaim that some predictions are lucky star predictions. And we should think about that, especially we have now a professional data portal. There will be another portal for data collector in the future from the amateur side. And what I want to say is, I have a little bit the feeling that they are, instead of coming together, they separate more. And that is one of the reasons why I like to have some discussion. You understand?
Yeah, if this professional data collection portal collect all observation, then I would be fine with it.
So okay, that's my to think about. Like, it's a little bit.
Now there is a point that Lucky Star was started with the European funding. I think. That European funding requires that all the results are public, so they don't belong to us, to me. Okay. So in principle, anybody can go to the Lucky Star page and use a prediction and does his or her own analysis. So there is no obligation that the Lucky Star event. I mean, it's fair play, but it's not necessary. So, and the ERC would say, okay, well, this is public money. You have a public page, and anybody should have access to that. So suppose there is a very interesting chance there is an object and there is a ring discovered thanks to Lucky Star. It's by definition, it's public and it's used for that. So it will be hard to argue that we should have the data in priority. I mean, we should, of course, because it's fair play, but strictly speaking, this is public funding.
Yeah, but I have to emphasize that we are supposed to have a time to analyze the data before releasing them. I mean, we are forced to release the data at some point, but we have some priority time. I mean, in which we are supposed to do the analysis.
No, yes, but my point, suppose there is a big team in Japan observing one of the Lucky Star candidates. They will observe it. We don't do anything. They observe something which is really interesting and new, and they may say, okay, we have the data, we analyze them, we publish a paper, and we thank Lucky Star for that. And it will be hard to argue, no, you should have sent us the data. I mean, it's different if we organize a campaign and we tell them to do this and that, but there's so many events that there will be at some point, there will be an event that we don't consider very important. We don't organize anything, and it's lost in a list of thousands of events. And someone will discover something interesting. So usually they will say, okay, they will contact me or some other person, say, oh, that's something interesting, or like that, this is in your paper. But the person can say, okay, well, it's really interesting and it's really hot, and I will publish that to Nature, and I will thank Lucky Star. It will be hard to say no, you cannot, because it doesn't belong to us, it belongs to the community. So there is a fair play, of course, but at some point, I think that so many events, and very accurate now, that this problem will arise, not now, but maybe in some years. I remember using prediction by some MIT group in the 80s or 90s, and I was using their prediction, and I was observing the events, and they were observing the same event, of course, and each of us were publishing the data separately, and they never asked me, oh, you should give us the data because you use our own prediction. I was just saying in the papers, well, this was based on this prediction made by these people, published in this paper, etc., etc.
So a summary, maybe some specific campaigns should be treated as a professional, but some observations, serendipitous observations from TNOs or spatial bodies, they can be considered as public observations.
I mean, it's nice because many people observe and at some point we'll get, I mean, we'll get the return.
Yeah.
And in some cases, we will not. But you have to take the risk because.
Yeah, I think there's a little difference in the case that you mentioned, because if you use the prediction that is published by a team, then you cite that in a publication. But in the case of the Lucky Star, they cannot cite a publication. They can maybe just say that they got it from a link. It's not exactly the same. So,
but at least I have to name the source.
Yeah.
For the prediction. This prediction is made by this and this scientist.
Yeah. Okay.
Complicated.
So no, it's not so complicated.
But it's not complicated.
People need to understand
yes.
What are the data for you and what are the data for us. For us, it's more or less a little bit fun, and next day you want to be happy to talk about this. And for us, the job ends very often with the observation and the light curve analysis. For you, the job starts with the light curves.
Yeah, but considering the discovery of Kawa's rings, it was the dense part of the ring we discovered last year by 3 amateurs in Australia. And then really believed there was something because the rest was tenuous and small drops. And then there was they started the discussion in the forum with several people involved. And at some point we said, okay, we looked at the data and there is a consistent explanation, which is a ring. So could you please just not spread the news and the stuff? And they're very happy to be in the newspaper.
Most of the people have full understanding.
And then there was some leaks, and some colleagues of mine in the US told me, oh, it looks like they observed something last year. And I said, yes, observed something which is probably material, but it stopped there and there was no problem. So, I mean, in general, there is no problem.
Yeah.
Okay. But we should expect that at some point there will be some people who are not so nice and not so fair way, I think, as always.
We have
there has been a similar story has been in the past in preparations of occultation observations. So I remember I don't know who it was, somebody wrote, please don't spread it, because we have first to announce observation time at the big telescope that they're not filled out. So what should we do as amateurs? I mean, I didn't spread anything around, but maybe some people say, well, if they would know, well, why should we do this? And also because the time also the observation time of amateurs is limited. I mean, it may be that for family reasons, for job reasons, so you cannot observe every night everything. So you may say, if there is an important thing, then you put your time schedule you have onto this observation. But if you don't know it, if you know it, then perhaps you said the week before, then publish it. And say here a week before, but maybe they have to go to a family festival or whatever, and then they won't observe. So this is similar. I think this is a similar situation as this afterward. So how should this be in the future? Because I can understand it. I mean, because you produce data who are not every astronomer in the world can do, even not professionals. Because now it's a little better, I think, because of Gaia. I mean, the star positions are relatively good. I mean, everybody can go to star positions with a precision where we would 10 years ago would be just saying impossible. Yeah? But it's still with the TNOs, with the minor bodies, they need really some orbit refinement. So, and then I can understand, it's the same thing.
I can understand that you say, well, we first have to look for our community to block the telescopes. There was also once an American situation once years ago, also tried to block things. And so what you're feeling to this, because it hampers a little the observations, maybe. If the amateurs or if the unpaid astronomers get the information too late.
Well, I mean, the applications are 6 months before in general. So it leaves time to apply, and then you have several months before the event. So is it really a problem? Because
well, it was in 2 applications, it was a problem. Then you say, well, don't spread it around, and then we get the week before. Then we get somehow the allowance to, or you published it and published it.
Yeah, but this is another problem. So because update has to be done, wants to be done just before the event. It's an unrelated problem.
Okay, in case of a last minute prediction, you cannot expect that
This is
plan for months.
This is a technical problem.
Yeah.
It's not, but now it's not so much a problem.
But I think in the last time we have not encountered this problem. No.
Maybe it's
we have
wasn't history.
Yeah. We have time.
Yeah, we need to close the roundtable because there is one more presentation for the next top meeting, and that person is waiting. Okay?
Yeah.
You said so. Yeah, it's closed or make a summary now. It's closed.
Thanks to Mike for this surprising.
Yeah.
We hope it has been useful.
Yeah. So there is the last presentation of the meeting is by Apostolos Christos. Are you there?
Hi there. Hi again. Right.
So you want to share the screen or?
Yes. Yeah. Just give me 1 second. Let's see. See if this works. So can you see this?
Yes.
And I'll launch the presentation. Okay.
Yeah. We see in presentation mode, but maybe you can change that.
Let me check. You should be seeing just the one.
No,
just the one slide. Just a minute, because I have a repeater screen on my left here. So
go up left and swipe.
Yes. Okay. How about now?
Yes, only one slide. Yes.
Excellent. Okay. So how much time do I have? Quick question before I start.
Yes,
how much time do I have?
5, 10, 5 minutes. 5 minutes.
Okay. Okay then. So okay, I better start then. Okay. So hello again. I'm Apostolos Christou. I'm now wear a different hat to the one where I presented my work earlier on. So now I am acting my capacity as member of the LOC for ESOP 42. Will be held next year, and I would like to present this proposal that we have put together to hold the 42nd ESOP meeting in the city of Armagh in Northern Ireland between the dates of the 15th to the 19th of September next year. So right, so I'll start with the venue for the rather the proposed venue for the meeting. this will be at the Armagh Observatory and Planetarium. This is an organization that has a number of functions apart from research. It also carries out education and outreach. In terms of the physical location, AOP is composed of those two building complexes that I show in this slide. So on the left, you have the planetarium, and on the right, you have the historical observatory site where, incidentally, my office is. Okay, the AOP goes back quite a while. It was founded as the Armagh Observatory by the Archbishop Richard Robinson in 1790, so it's now over 200 years old. Its mission was to carry out astronomical research, and as such, it has been doing this continuously since its founding. And in fact, the exhibits that we have available at the historical site, if you like, mirror the development of astronomy from the times where, for example, in the late 18th century, where, say, one of the major problems was to find a way to determine longitude at sea, to the later times where astronomy became more international and was carried out through facilities funded by multinational consortia. So the next major event in the history of the observatory was the founding of the Armagh Planetarium in 1968, 1 year before the landing of Apollo 11, and this was intended to be the outreach arm of the observatory. So almost 50 years later on, the observatory and planetarium were merged under a common management structure to form the Armagh Observatory and planetarium. Now, however, the observatory is still very much active as the research arm of AOP. The astronomers at AOP carry out research on a number of areas, covering essentially all the major areas of astrophysics, except cosmology. And this is in line with our mission to be able to support the planetarium in explaining astronomy to the public. Also, the observatory happens to be the longest continuously operating astronomical research organization in the UK and Ireland since Greenwich Arrow, the Royal Observatory, Greenwich, terminated its research function in the late 1990s. Okay, so a bit about the city of Armagh. In some ways, it is a very fitting location for the observatory, which I mark here with the red rectangles. The observatory is only like a few hundred meters from the city center. Armagh is recognized as the ecclesiastical capital of Ireland, being the seat of both the Roman Catholic Church in Ireland and the Anglican Church of Ireland. So it is host to two separate cathedrals, and both of them are named St. Patrick, but of course they are of different denomination. It's also known as the city of saints and scholars in reference to this strong education function of many of the buildings and institutions in the city. Historically, the Armagh has been a center of human activity for thousands of years. The earliest artifacts that have been found go back to the 3rd millennium BC or even earlier. So there's a lot of history to be explored in Armagh, apart from ESOP, that is. There's a nice palace on the south, which used to be the Archbishop's residence, and this goes with stables and the grounds, which are has place to walk around and perhaps have a picnic in. If we move further afield, I suppose, well, there's a whole lot to see in Northern Ireland and the Republic of Ireland in the south. Over here, I'm trying to focus on some sites of astronomical interest. There are 3 historical observatory sites in Ireland. One is Armagh, the other is Dunsink Observatory near Dublin, which is actually a very Armagh, the architecture of the observatory actually imitated the architecture of Dunsink. Dunsink is in fact some years older than the observatory, but because it has ceased for some years to be a site of active astronomical research, Armagh still has the title of the longest continuously operating observatory in the UK and Ireland. Also, there's the famous Birr Castle in the middle of Ireland, of the island of Ireland. There's perhaps you have heard of Lord Rosse and his famous Leviathan telescope, which was used to understand the structure of galaxies. If you remember, these are first thought to be nebula within our own galaxy, and then through the investigations by Lord Rosse and others, would attempt to be galaxies different from our own. Going even further back in history, there are sites of astronomical interest going back some thousands of years. For example, the Beckmore's stone circles Circle site is, if you like, something like the Stonehenge of Ireland. It is used for some astronomical purpose or for rituals and ceremonial purposes by the dwellers in the Neolithic age. Some practical information, right? So Northern Ireland, where Armagh is one of the 4 nations in the United Kingdom, the other being Scotland, England, and Wales. The official currency is the pound, and that's actually, people find it strange that in the same island you use both the pound and the euro, but Northern Ireland is actually the only nation of the UK with a land border in the south to a non-UK nation, that being the Republic of Ireland. And since 2020, with Brexit, this became the land border with the European Union. So, in a nutshell, north of the border we use the pound, south of the border we'll use the euro. However, near the border where Armagh is, for practical reasons, you'll find that many of the shops accept both. Yeah, so so this is my final slide. So in terms of how to get to Armagh, Armagh is actually fortunate enough to be served by 3 airports. The nearest one is Belfast International, with less than an hour's drive. There's Belfast City, a little more than an hour away, and of course Dublin International Airport, which, although it's the furthest one out, it's preferred by many individuals because it offers more choice of airline and also better prices. One note that I've inserted here is that Northern Ireland does have a rail network, so you can take the train, for example, from Dublin to Belfast, or Belfast to Londonderry, or Galway, but Armagh has no train station for historical reasons. And if you ask me, I can explain why that is, but the nearest station is in Portadown, which is a town, say 20 minutes away by car. So to get to Armagh, you can't do the whole trip by train. You either have to take a taxi, take the bus, or hire a car. So I suppose that concludes my presentation. We think we can, I think in the LOC, after several discussions with Conrad and also internal discussions within ourselves, we feel confident enough to be able to make this proposal and feel that we can make this a nice experience for IOTA members. So I will look forward to welcoming you in Armagh in a year's time. Thank you very much. Sorry that this took a little bit longer than you had budgeted, but
okay, thank you.
Yes, questions? Should I stop sharing, or?
Yes, as well. I don't know. Okay. We can, I don't know. No, there is a question here.
So
approach to the.
You go ahead.
Yeah. It is not a question at all. It is Alex Pratt from Leeds, Tullis.
Ah, yes, please.
Thank you for your presentation. I visited Armagh a few years ago for the BAA weekend with William Stewart, and you gave us a very nice private tour of the observatory and the grounds and the solar system walk, etc. So I am sure people will enjoy visiting a different part of the United Kingdom. And we will help you with anything we can with LOC or advice. And I look forward to seeing you again.
Well, yes.
Friends there from the Republic, from Dunsink Observatory. So from the Republic of Ireland and Northern Ireland. So thank you again for your invitation to ESOP next year.
Yes, yes, I think, well, I suppose I should say that, well, we can use all the help we can get, and B, you know, I think what Stuart mentioned reflects the experience that we hope ESOP participant will have in a year's time.
There is a question on the chat, the maximum number of persons that can be in the meeting.
Okay, well, that depends really on, this really alludes to auditorium capacity. Okay, so, the simple answer is that the auditorium that we have baseline can take in excess of 100 persons. So if people really want to come, we can accommodate them. So that's no problem. And also there's plenty of hotels and beds and breakfast accommodation in the area to be able to offer everyone somewhere to stay.
Yeah, Tolly's Conrad speaking. Many thanks for your friendly invitation to the United Kingdom, to Ireland, to a new country for us and a well-known country from other ESOPs. It was England, Yorkshire, and the area around London, Guildford. So we are really happy and we are curious to meet you and your colleagues and new friends. Maybe we can spread out the occultation network a little bit more to the Irish island. We will see, and we say thank you for this and thank you for your preparation you have done so far. If you have any question, feel free to contact IOTA.
I think, yes, I think key to this proposal is really the continuous communication that we had so far. So this is actually just crucial. The only thing that I want to comment at this stage is that people should not be scared of Brexit. So the Northern Ireland is still a very welcoming place, and in fact for free transport of individuals, the situation is very much as it was before. So
that's nice to hear. This was some concerns from people in private discussions we had here. It is nice to hear, and we will be happy to see how it works, and we'll enjoy it.
We will provide full details of what the participants should expect when they enter the UK in due course. So
okay,
we are aware that this is a potential source of worry for participants.
Good. So far, so we know where we met us next year. We have learned a lot of things. We have plans, what's to do in the next months. We had nice information about observation next year. We discussed what we expect in the annual rotation of the bright star in Orion. A lot of new things for us. We have private discussions, we had fun together. And for me, it is nothing to say. Yeah, it was fantastic. It was nice to be here. I say thank you. I say also thank you for the patience in the world in Zoom. Maybe we had some technical problems and the sound was not so easy, but that's the problem when you stand here. You sometimes forget that some 100 people or some dozen people are in the world and need a microphone, what you forgot in this room here. Please forgive us. And maybe my board colleagues ask me, I shall remain you to the donate button. We need the money next year for the ESOP in Ireland and for all expeditions and plans we have. Thank you very much. Thank you to everybody who was here. Thank you for the friends here for the good service, for the perfect troubleshooting when we were wrong in the computer world, and have a safe trip home. Enjoy the coming days so we stay together. So why should I say bye-bye or something like that? We see us in the next hours, in the next 2 days. So far for today. Thank you. Thank you. Thank you.
Para las excursiones.